Hi, so in this video we're going to look at example on flux. Alright, so we have the vector of f, which is of xi plus yj plus zk, and you're supposed to find this flux that goes through this cone of z given by square root of x squared plus y squared. Alright, so again we want to look at our flux formula, which is given by double integral of my flux dot n cap ds. Alright, if you recall, my n ds can also be represented as negative I df over dx minus j df over dy plus k dA. Alright, let me just write this slightly nicer. Okay, so this dA. Can you see this? So this is dA. Alright, so okay, so let's get started with this. And of course, when I have first of all the identification of my f. Okay, so in this case, same goes my f given by my z. In this case, it already is given as such, is square root of x squared plus y squared. And so I can express it in terms of x squared plus y squared to the power of half. Yeah. And then what do I need to find? And I will need to find these two terms here. Alright, so once you have found out the formula and you know that this n cap ds actually indicates this, just in case you're wondering how do we get this equation here, you may refer back to your slides in your lecture note, because you already have, this is actually a simplified version or the after product of simplification from your n cap dot ds. Alright, because earlier, if you remember correctly, you already have your ds, or if you want to try it yourself, you have your n cap formula and you have your ds formula. So if you combine both and then you put them together, you come up with this xt expression. Alright, so let's get started. First, I want to get my df over dx. Again, partial derivative of this will then give me half x squared plus y squared. Differentiation, right? So this will give me power of negative half multiplied by the expression inside here, the differentiation of the expression here, which will give me 2x. So in this case, upon simplification, this gives me x over x squared plus y squared. Alright, similarly, let me just put this up, df over dy, isn't it? So df over dy, same thing goes, I have half x squared plus y squared, power of negative half, multiplied by 2y. Alright, therefore it gives me y over square root of x squared plus y squared. Now that I have this, I can put this and this into my equation. Alright, so let's start with n ds. Alright, so my n cap ds, you can see it from the top here. Yeah, so I'm just going to replace everything back as it is. So negative I will be the same. Alright, so my df over dx will be this. I just try to squeeze this a little bit. And then I have minus j. And then I have y over square root of x squared plus y squared and plus k. Alright, I have this and then I have my dA, isn't it? And by the way, I can also express this, since this is of a limited space. But anyway, limited or not limited space. Do you know that we can actually express this in terms of the matrix form as well? So if you recall, our flux is actually, all right, let's not go to this, but my flux earlier is F dot n cap ds. Remember this dot here basically means the dot product, all right? And if I let's just solve the thing that's inside here first, all right? So I want to get F dot n cap ds. And I can actually express this in terms of, what's my F? My F is actually X, Y, and Z. Yeah. And then so F is given by X I plus Y J plus Z K, right? If I just scroll this back up a little bit, so it's this form here. So I can replace this in terms of X, Y, Z. All right. Now, my dot product for my N. So for I have actually negative X over square root of X squared plus Y squared. For the Y part, I have negative Y over X squared plus Y squared. And finally, K. Don't put K here. It's going to be 1, right? So we take the coefficient of those. And this is F, this is N cap dot product, right? So ds can be replaced as my dA. So in this case, do you still remember your dot product? Dot product basically means you multiplying each coefficient of your x, y, and z component and sum those up together. And dot product is a scalar or vector unit. So you got it right. Dot product itself would be a scalar unit, alright? So you don't have any I, j, k component in there. So now when I do a dot product of it, basically this is 1 dot negative 1 over, so this is what it looks like. When I perform a dot product, then basically what I get is, I'll just put these together. It's not 1 or negative 1 earlier, yeah, sorry, because this is I, j, k component. So this is actually the coefficient itself already. So I will get negative x squared over x squared plus y squared. Alright, then I have minus y squared over x squared plus y squared plus z dA. Alright, and then from here, if you recall earlier, you have a z component here, isn't it? And then do you recall what is your z earlier? Your z is actually here. Right? So because your f is being expressed in terms of its y, x and y equivalent. So now you see that you actually have a z here. So you can just replace this with its equivalent, which is the square root of x squared plus y squared. Alright? So if I just put this together, right? Now it becomes what? Then I can put a common denominator for it because of this. So I'll just multiply a square root of x squared plus y squared over square root of x squared plus y squared. This gives me negative x squared minus y squared plus x squared plus y squared, right? But remember, since we are multiplying this over another term of this to get the common denominator, in this case, this form here, so I'm going to multiply it again with another x squared plus y squared. Alright, This then will lead me to what? If I just rewrite this again, it gets rid of my square root, right? So let me just change this back. So when you see this, basically what do you get? You basically get 0, right? So 0 is the answer, all right? So as you have viewed here now, every time when you have a question, you want to get your, of course, you want to make sure that you get the formula correct, all right? After laying down the formula, then you want to express this in terms of its x and y, all right? So if it's x and y, then of course your unit vector normal will be in terms of x and y. Say if you decide to not put it in terms of x and y or x and z instead, then just make sure you just change this accordingly, all right? Your unit vector normal will then be in terms of dx and dz. All right, the way for us to change it is already explained in the previous video, so I'm not going to go through much with it. And after that, you just basically find according to the formula and then perform the dot product where you get the coefficient of both f and your n cap ds, and then you perform the dot product in which you just get the coefficients, multiply and sum those together. And then in this case, just so happen that it's 0, therefore the flux itself, even with the integration, that would be 0, all right, because you basically do not have anything there. So that would be it for example of flux. In your lecture note, you will see quite a number of examples, so good luck in trying and feel free to discuss with your friend.